All right, good day, everyone. Today what we're going to be discussing is going to be function composition. Basically, if I was given an f of x and a g of x, how could I combine them together and what different operations can I use that with? A lot of this is going to be using with function notation as well. And then on top of all that, we're also going to be understanding things about like domain and range. So just kind of start this off, okay? Function composition is basically what you see right here, okay? On this page, these different types of values is our function composition, okay? Where I could actually take any sort of f of g of x or f of x and g of x or anything like that, write it as so, but that representation is going to be as we see to the right here. Okay, so that's kind of the first main thing we want to understand is that function composition is just a set of operations we can do with a whole function. Okay, now I think notation for a lot of this is going to be half the battle. For example, we understand if we have f times g of x, it's written out just like this versus if I was given this value, which means I'm going to be plugging in the g of x and the f of x function. Okay. There's a big difference between the fog and golf function, as I always call them, and the other values. Okay. And so we just kind of want to talk about through those function compositions today and just kind of understand that there are differences. How do we actually solve them out? How do we actually work through them? And then most of all, the one thing that we were going to start to discuss is the domain and range of each of these functions and how it changes and how it actually grows from that. Okay. So what we're going to do is jump all the way down here to letter A. And what they want us to do for letter A is they basically want to find the sum, the difference, the product, and the quotient, which is going to be all four. Okay. So the sum, we'll start off with that, is just f. Oops. The sum is just f plus g of x. So if I want to work this out, easy enough. I'm just going to take the f of x function, which is 3x minus 4, and I'm going to add that to 4 minus x. If I work this out, negative 4 plus 4 is going to cancel. 3x plus negative x is going to be 2x. So this function would equal 2x. Now, what we want to do is define the domain and the range of that value. Well, in this case, I shouldn't have any restrictions, okay? Domain is my values of x, and I shouldn't have a restriction on x here, okay? So my domain is all real numbers. My range would be, is there any value that I can't obtain because I cannot plug an x in? Well, in this case, no, because if you think about it, 2x, you can pretty much get any answer you want. Okay? Now, that was just kind of the first one. I just want to talk about that one. Now, we can obviously go through and actually like work out each and every one of those values, but I kind of want to continue on and start talking about ones with a different domain restriction, okay? But that's kind of the idea of that is how we can actually cancel those out and actually just solve for domain and range based off the function composition. But instead of going through and doing all of these separately, let's just talk about letter B here, okay? So if this is letter A, we're going to do letter B down here. And for letter B, we're going to start with doing the quotient. Okay. Actually, let's do the product. Excuse me. Let's do product first for this one. Okay, so for those of you who don't know vocab, or those of you kind of learning this, still product is going to be your multiplication. So we're going to go ahead and take letter B, x squared plus 6, and multiply it to the absolute value of 1 minus x. Okay. Now, the kind of interesting thing about this is that really all this becomes is like a foilable factor. Okay. So for example, if my equations were, if I want to do f times g of x, this would become my first formula, which was going to be x squared plus 6 multiplied to the square root of x, which is going to be 1 minus x. This would be 1 minus x. Now, technically, I would have to FOIL this out and multiply it through, but this is all its own function. So I really can't separate those values. So really what this would become would be x squared times that, 6 times that. So this would be x squared times the square root of 1 minus x and plus 6 square root of 1 minus x. So now we kind of run into a situation of what can't I actually plug into this problem? Okay, what is going to be my restrictions for these values? Okay, well, and that's the thing that I truly want to understand. It's kind of one of the things that you want to try to think about, like how would I actually get this? How would I actually work this out? Well, a couple different ways you could look at this. How I look at this first is if I'm going to deal with this function, I want to try to state the domain. Okay, so right now we don't even need the range, we just want the domain of this function. Well, there are going to be two very basic things in math that really restrict our domain. And the two basically are, first and foremost, I can't ever divide by a zero. So in a lot of our division problems, you'll kind of notice how, like, if I have an equation on the bottom, I need to restrict it so I never get a zero. The second one is I can never take the square root of a negative value. Well, if you notice, this is kind of the first problem where we see where we might have a restriction. Okay, we have a 1 minus x in that square root parenthesis. So I'm trying to think, well, what would x have to be to make that negative? Well, if x was 1, my answer out of both of those would become 0, which is fine. I can have a 0 under the square root, but I just can't have a negative. So what I want to do is basically state that for my domain, x has to be less than or equal to 1. Because I state that, now I'm basically saying that I can use any value of x besides anything greater than 1. Because if I would plug in like anything bigger than 1, for example, 2, both those square roots would become negative. So my answer becomes this value. Okay. Now for the last one, we're going to go ahead and just jump to letter C. And we're going to do the quotient for that one. Actually, no, never mind. We'll just do letter B because we want to get kind of the same idea here. So let's go ahead and work out letter B for the quotient one as well. So let's say I'm doing division here, okay? Which is just F over, F over G to the X, okay? So if I were to take both those values, truthfully, there's really not much we could do here, okay? So currently, this is the position I'm at. Well, to simplify this, what I would need to do, because I can never have a square root on the bottom, I would multiply top and bottom by 1 minus x. Okay, that way I get rid of the square root on the bottom. Well, if I do that, I'd be left with f over g of x is going to be equal to x squared plus 6 times the square root of 1 minus x. Okay, we could leave it like this. Or we could, I'd actually recommend just doing the parentheses, make your life easier. And this would be all over 1 minus x as the value. Okay, and currently this is the most simplified version. Honestly, with division, not every time are you really going to get a truly simplified equation. A lot of times it's just going to end up like this. Okay, does not say that sometimes it can be simplified. Okay, and we'll actually see those at some point later this week. However, now we want to try to discuss what is the domain of this function. Well, here's kind of how I look at this. Whenever you're doing function composition, you can't just look at your end result. So I'm not just focused on this. I'm focused on two specific things. First off, I want to go back to the original, right? I want to go back before I even simplified and basically say, what was my domain restrictions up here? Well, we have our square root on the bottom there. So we know that we can't have a negative value, and we also have a value on the bottom of a fraction. So not only can I not have a negative number because it's square root, I also can't have a 0 because then I'd be dividing by 0. So my thought process is, how do I keep these values on bottom from being negative and 0? Well, if I plug 1 in for x or anything bigger, that would give me a 0 or an actual negative value. So for this one, it just changes slightly. X is less than 1 now, okay? For the first one that we just did, we could actually equal the 1 value. But unfortunately, now that we're below the fraction, now that we're on bottom, we can't have that. So now, when we move down to our bottom function here, this square root sitting right here can't be forgotten about. I can't automatically change this next domain to x can be less than or equal to 1 because the square root's gone on bottom, okay? This whole principle or this square root function or the domain of it has to follow with the equation. I can't just say that it just disappeared because technically I used mathematics and it's there. We just haven't moved in a different location, right? So what happens is my domain actually stays the same, simply because even though it's gone on the bottom function or in this final simplified version, technically it was there to begin with. So that means I have to restrict it at that point. Okay. And that's the function composition of this problem. Now, that's kind of the main idea of it, where I just have to graph it out, or excuse me, I just have to actually work it out and try to show each of these values being added, subtracted, multiplied, or divided, and then state the domain based off my work that I went through. Okay. So the next portion is going to be dealing with things like piecewise functions. Okay. So first off, they want us to graph this function, x plus 2 and x squared. Now, what I'm going to do real quick is kind of explain like how would I actually do this, how would I actually work this out. So what we're going to do is quickly graph out the piecewise functions and then talk about how can we relate this back to the actual values that you see in front of you, okay? Because it's kind of a interesting concept overall of trying to like say, okay, well, how would I actually work this out? How would I change this? All right. So first and foremost, we got to understand how a piecewise function is supposed to work, how it can actually use the information here to actually graph it out. So excuse me one moment. I'm actually just going to grab a graph to make this a little bit cleaner for us. Perfect. All right. So letter A, they want us to graph out this piecewise function. So first and foremost, if I'm ever graphing out a piecewise function, I have to understand that basically what this means is I have a function, and what I'm doing is I'm basically breaking this down at a specific restriction. So in this case, we have a restriction at 0. That tells me if I put a line through 0 here, that we're going to have a graph on this side, which is going to be the x plus 2, and on this side, which is going to be the x squared. How I know that is because based off the information given to me up here, they're telling me for x plus 2, you can't have an x bigger than 0, which means the left side of the graph. And then for the other one, x squared, you can't have an x value that is less than 0, so the right side of the graph. Okay? Now, there are a lot of different ways to do this and actually graph this out, and we'll talk about some of these ways in class, but the easiest way would be to literally just take two different graphs like this and literally just plot each one. Okay? So, for example, how I could do this is x, y, x, y. Each of them are going to start at 0, while the x plus 2 are going to go to the left, so all my negative values. The x squared is going to go to the right, which is going to be all my positive values. Which, if you think about each of these, is going to come out to give me those coordinates there. So I'd plot each of those out. Go ahead and do this one in red. So this would be x plus 2 starting at positive 2. I'm going to do an open circle because I have the cannot equal to inequality up here. And then plot two other coordinates to get a line like so. Well, on the other side, I can do a closed circle there. And I apologize. The other one doesn't really look like an open circle. I'm going to open this one up a little bit. While the other one, we have a point at 0, 0, 1, 1, and 2, 4. To get an x squared function that looks similar to this. Okay? Now, domain and range of the piecewise function, there's a lot of different ways you could look at it. I always consider the two things, both the algebraic way of understanding, like, can I have a restriction here? And on top of that, looking at your graph. When I look at this graph, I see values going left, right, up, and down. There's really no restricted area. So in this case, domain and range are going to be both all real numbers. Okay, there's really no restriction here. There's not a value of x I can't plug in. There's not a value of y that I can't get as an outcome. Okay. And in the second portion, letter C, what they're asking you to do is find the sum, difference, product, and quotient of each of these functions. Now, I'm not going to go through and solve out each and every one of those just because it is kind of tedious and I don't want to waste your time on the video. But the whole idea is that I would just take this q of x and plug it into each of these and multiply it out. So for example, just a quick one, if I was doing addition or the sum, I would take p of x, which is just, oops. So if I had this same piecewise function, x plus 2, x squared. If I want to do this piecewise function, this would be less than 0. X is greater than or equal to 0. If I want to take this piecewise functions and add the q of x to it, so if I want p of x plus q of x, all this really means is I would take both those values and add it to it. So I would take x plus 2, and I would add my q of x, which is x plus 3. This would become this plus x plus 3, and then my restriction would just stay the same. Same thing down here. We'd have x squared plus our q of x, which is just x plus 3. And that one was when x is greater than or equal to 0. So all I'm doing for function composition in a piecewise function is I would take whatever the other function is and follow with the exact operation they want me to use. So if I wanted to multiply, I would take this function and multiply it to both of these. Okay? And that's really the whole idea with that value. All right? But besides that, that's kind of the whole purpose of today's lesson. All right, piecewise function, we're kind of dealing with function composition built into it. While on the other side of things, the function composition, which is the first thing we did, is just dealing with simplifying and trying to combine functions based off the 4 different operations and then being able to state the domain there. Okay. Besides all that, make sure you answer the questions in the Ed puzzle, and I will see you in class. Have a great day.